This is section 5.2, which is properties of rational functions. Okay, so we're going to start with question number 14, which says find the domain of each rational function. This is a guaranteed test question. Okay, definitely. I think she has put this on every single test. Guarantee it will be on the test. Maybe not this exact problem, but the concept will be on the test. Okay, so if you remember, all you have to do is set the denominator equal to 0 and solve. All right, so we got x plus 3 equals 0, and then 4 minus x equals 0. You're going to solve for each piece. We're going to minus 3 on both sides, so x equals negative 3. Over here, we're going to minus 4 on both sides. We have negative x equals negative 4. Divide by negative 1. We get x equals 4. So your domain is all real numbers except for negative 3 and positive 4. So x cannot equal negative 3 and x cannot equal 4. Okay, next one we're going to work on is question number 26. This one is like a multi one, so there's lots of questions based off of it. So we're going to start with graphing the picture. Okay, so it has an oblique asymptote at -1, +1. It cuts through 0, 0. So we're going to draw that as a diagonal line. And then it says the point is at -1, +2, and it goes down right there. And then the other one is at +1, -2, and that cuts down right through here. Guys, I'm really sorry, but my cat wanted to say hello to everybody. All right, so there's the picture of the graph. And question A. Sorry, we're having technical errors. And he literally just decides to sit down on where I'm working. So I'm going to have to remove him. I'm really sorry about that, guys. All right, question A asks, what is the domain in the range of the function? Okay, so domain is the x values going this way. So it's going to be everything except for right here, because it's never going to cross the y-axis. So your domain is going to be negative infinity to 0, union 0 to infinity. So that's going to be your domain. And then it asks for the range. So the range would be the y-axis. So you're going to need to know that point there. So it's going to be negative infinity up to this point here, which would be -2. And since it includes that, because it's a solid, you're going to get a bracket, union, and then the next one is going to be 2 to infinity. Okay, so there is A. Question B asks for the intercepts. So we're never going to cross the y, we're never going to cross the x, so that would be none. Okay, question C asks for any horizontal asymptotes. So that would be going across the horizon. So if you look, there are none. Okay, question D asks for any vertical asymptotes. So it's not really drawn on there, but it's kind of implied that it's never going to cross right here. So that would be x equals 0 because we cut through the x-axis. Okay, question B is any oblique asymptotes. So you're going to have to find the slope through that and the y-intercept. So the y-intercept is 0. And then you would start on the left dot and count to the next dot. So we go down 1 and over 1. So your slope would be negative 1 over 1, which would be negative 1. So put that into y equals mx plus b. So y equals negative x. And then you don't even need the plus 0. All right, next one is 34. Graph each rational function using transformations. Verify your results using a graphing utility. Okay, so they give you this equation, 2 over x plus 2 squared. Okay, so in order to graph this function, really best to know the base function. So I'm just going to kind of do this as like a little afterthought. So if I have 1 over x squared and I was graphing just that without adding anything to it, your graph would look like this. So it would come down like that. You would have a vertical asymptote right here through 0, 0, and a horizontal one going this way. Okay, so this is the base function. So you're looking at this function. This down here shifts left and right. Okay. And then if I had anything over here, that would do up and down. There's nothing over here, so up and down would be 0 on this specific case. All right, so since this is a positive and it's in parentheses, you're going to go left. If it was a negative right there, then we would go right. So this specific case, we are going to go left 2. All right, so we're going to draw our graph. And all we're going to do is shift this main line over to the left 2. So that's going to get shifted over to the left 2. You're going to have your other mainline graph going right through there, and you just go right up to it. You just don't cross your asymptotes. So this would be your answer for number 34. I'm going to do a couple other ones that are not on the actual bookwork problems. I'm just going to kind of make them up. All right, so the next one is going to be 2 over x minus 1 squared plus 3. Okay, so since that's a negative, we're going to go to the right. So this is going to go right 1. Because it's in parentheses, it's backwards from the coordinate grid. Since this is a plus 3, it's not in parentheses, so we're going to go just normal up 3. Okay, so we're going to go up 3. You're going to draw your dotted line going up 3. You go right 1, draw your dotted line going right 1. And then you just draw it this way. Okay. All right, the next one, I'm going to put on the back here. So it's 2 over x plus 3 minus 1. Okay. This main base here is different than the other one because it doesn't have the exponent 2 on the outside. So let's look at what that main base would look like. So if we were just looking at 1 over x, okay, again, you're going to have your asymptotes following your axes. And then your main graph is going to be in quadrant 1 and quadrant 3. So this is the main graph. So we're basically going to shift this main graph. So down here, because it is plus 3, it's going to go backwards from the coordinate graph. So we're going to go left 3. And then the minus 1, we're going to go down 1. Okay. So draw our graph. We're going to go left put your dotted line. Go down 1, put your dotted line. And then you're going to kind of use your dotted lines as your quadrants instead of using the original quadrants. So you're just going to follow your asymptotes around. So use that one and that one. If there was a negative in the front, then you would shift over this way. Okay, the next one is number 42. And in order to do this one, you're going to need to know a lot of information. So number 42 says find the vertical, horizontal, and oblique asymptotes, if any, of each rational function. All right, so you will need, in order to do this, this is going to be crucial, and this is definitely on the test. You will need to memorize this. And I'll summarize it here, but on page 355, there's a blue box. You need to have that blue box memorized, okay? All right, I'm going to kind of summarize the blue box. It's pretty wordy, but basically you are looking at your numerator and denominator, and you need to look at the degrees on them, okay? All right, so if the degree of the numerator is less than the degree of the denominator, okay, so if you have that, you're going to have a horizontal asymptote at the ratio. Or no, you're going to have a horizontal at y equals 0. I'm sorry, I misspoke. Horizontal asymptote at y equals 0. Sorry, my cat wants to join again. Okay, I'm sorry for the disruptions. Horizontal asymptote at y equals 0. All right, now if the degree is 1 more in the numerator than the degree in the denominator, you're going to have an oblique asymptote, and you would have to do long division to find that. Okay, you'll have an oblique asymptote, long division. That's how you would find what the asymptote is. Okay, if the numerator is 2 or more than the denominator, then you will have neither a horizontal nor an oblique. No horizontal and no oblique asymptote. Okay, and then if the degrees are equal, then you're going to pick off the coefficients in the front. You'll have horizontal, and you pick off the coefficients in the front. Okay, and this one is not that bad. You really kind of wish you have this one, or this one because it's the least amount of work. You really kind of hope that you never get this one because then you're going to have to do long division, and that's going to be much more difficult. Okay, so 42 says we have 3x plus 5 divided by x minus 6. Okay, so what you need to do is you look at these degrees. So you're looking at the exponents in the front. So the numerator degree on the numerator is 1 right here. Then you want to do the degree on the denominator. And that is also 1. So all we have to do is pick off the coefficients off the front. Okay, so it would be this over this. Now this doesn't have a number here, but it's assumed that it's 1. So you have a horizontal asymptote at y equals, and of course it would be 3 over 1, but 3 divided by 1 is just plain old 3. So horizontal at y equals 3, and then I think there might have been a little bit more. And then you need to find the vertical asymptote. Okay, so for the vertical asymptote, you set the denominator equal to 0. You will need to memorize that too. And I believe you have to reduce first. Okay. If you don't reduce first, then you might be setting a hole equal to 0. And you might not have an asymptote, you might actually have a hole there. And then that doesn't, it's not a vertical, it's a little bit different. Okay, so we're going to set the denominator equal to 0. So x minus 6 equal to 0. Add 6, add 6, so x equals 6. So we have a vertical asymptote at x equals 6. Okay, and then 52 is the next one I want to do. Alright, so 52 is the exact same directions as 42. So x to the fourth minus 16 divided by x squared minus 2x. So you need to factor the top and the bottom when you are doing this, because if things cancel out, then you will end up with a hole. So anytime something would cancel, you have a hole. Alright, and it would not be an asymptote. Okay, so x to the fourth minus 16, that's the difference of two squares. So you square root that. The square root of x to the fourth would be x squared. And the square root of 16 would be 4. Okay, you're going to do the same thing. One gets a plus and one gets a minus. Okay. Oh, one gets a plus and one gets a minus. All right, we are not done working this out. So then we need to do the denominator. So I'm going to have an x here, and then we can factor out an x minus 2 is left over. All right, if you look at the numerator up here, you can reduce that even farther. So the square root of x squared would be x. The square root of 4 would be 2. And then one gets a plus and one gets a minus. This one will not factor. It's just going to carry back over. Oh, that's a plus. Okay, denominator is going to carry down. Okay, and then you want to see if you can reduce anything. So this and this will cancel out. So there is actually a hole there because they canceled out. So you have a hole at, and you would set that equal to 0. X minus 2 equals 0, so x equals 2. So you have a hole at x equals 2. It's not a vertical asymptote, it's a hole. All right, your vertical asymptote, you set the denominator equal to 0. So the only thing we have left to set equal to 0 is x equals 0. Look at your coefficients, your degrees. So the numerator one is 4, your denominator one is 2. 4 is 2 or more than 2, so you have no horizontal and no oblique asymptotes.